8.5, number 17, sketch the graph of each polar equation. Since we're just kind of introducing ourselves to polar equations, I think that it would be okay to immediately allow the calculator to show what we have here. Then I'm going to show you how we could do it by hand. So the mode needs to make sure we're in polar. And if we go to r equals 6 cosine theta, the theta button is the same as the x button now. And then I can just make sure I'm zoomed in correctly. Alright, so it looks like an ellipse, but if I do a zoom square, let's make sure. Okay, so now it looks more circular. The axes are consistent on the x and y axis, so it is a circle. Looks like the center is shifted over at maybe 3, 0. So that would be my sketch. How could I do this without a calculator? Well, we could find the rectangular equation. In this case, I would multiply both sides by r, because I need an r to go with the cosine. I get r squared equals 6r cosine theta. So we know that r cosine theta is just x. That's one of our relationships between rectangular and polar. This is an x. And we also know r squared is x squared plus y squared. Okay, we have our rectangular equation. Now, what kind of shape is it? I'm going to move this over. I'm also going to complete the square. Half of -6 to -3 squared is 9, so I have to add 9 to the other side. So now I have x minus 3 squared plus y squared equals 9. And we need 1 on that side, so divide both sides by 1. So I have x minus 3 squared, well, over 9 plus y squared over 9 equals 1. You could recognize that this is since a and b are the same, this is a circle. It's a circle with a center at 3, 0, and the a and b radius, or just the radius in general, is going to be 3. So as we saw earlier, there's my center. I go 3 in every direction, and that's going to be my circle.